Here we have a function, and we want to find the blue area shaded above. So the blue area under the line, and the integral will be the area. So we've done this problem before, but we added up the area of the rectangle and the triangle, and it was tough. We're gonna do it this time with an integral, be easier. So first off, um, A and B are 1 and 3 because we're going from 1 to 3. So that's the first thing it wants to know, where does it start? Where does it end? 1 to 3. And then what's the function? There it is. How'd they come up with that? That's the line. So the function's the line. Let me help with that. So this line is y equals mx plus b, right? Because it's a straight line. Anytime you have a straight line, the equation is mx plus b. What is b? B is the y-intercept. Remember, that's where the graph hits the y-axis. So this is the y-axis, this is the x-axis. So that's at 4. So the b is 4. That part's easy. Now, what's the m? The m is the slope, remember? And slope is rise over run. So we got to find the rise and the run. How do you find the rise and the run? You go between any 2 points that are clear. Like I'm not going to do that point because I can't tell exactly how high or low that point is. It's not a good plan. I'll go from this point and I'll go to that point because those are right on grid. Here, let me get rid of that. Go between those two. Those are right on grid lines. So let's do it. So that means you go down 1. So the rise is -1. And then you go over 1, 2, 3, 4. The run is +4. Now you might say, well, why do you go this way? Go 1, 2, 3, 4. That's fine. The run's +4, and then the rise is -1. Same thing. Doesn't matter. So then we've got the equation. It's y equals the rise, -1, over the run, 4x plus 4. So there's the equation of that line, and that's what they got right here. They wrote it as a decimal. 1/4 is 25 cents, like a quarter, right? -1/4, -1/4, x plus 4. So there's that. Now, finally, complete the integral. So now that we know the equation of that line, if you want to know the area between a graph and the x-axis, do you know what you can do? You can just do the integral. That's what the integral is. It's the area. It's the exact area. So from 1 to 3, from here to here, of the function, which I now know is -1/4 x plus 4 dx. So if I just integrate that from 1 to 3 of that line, I'll find the area between the line and the x-axis. That's what an integral does, is gives you the area between any graph and the x-axis. So how do we do that now? Well, to do that now, what we learned is that the integral is the antiderivative. Here, let me go back and just make that -0.25. Just like it does there. It's be easier to have decimals. So now we're going to do the antiderivative. That's what the big discovery of calculus was, is that the integral is the opposite of the derivative. So if you want to do an integral, you do the opposite of the derivative. You do the antiderivative. Well, how do you do the antiderivative? You know that. Here's the 1 power. You add 1. Instead of subtracting 1 from the power, you add 1. So I'm going to take that -0.25. It'll be x squared, and then divide by that number. Plus, and then what's the antiderivative of the 4? Be 4x. How do you know? Because you took the derivative of 4x, it would go back to 4. So the opposite is 4x, right? But now what about the 1 and the 3? Right. You have to plug in. I'm going to put them over here, is what we usually do. We have to plug in the values. We're not done yet. And notice I didn't put the plus c because we're going to plug in actual numbers. We don't need a constant. We're going to plug in actual numbers. So here we go. So now what that means is you take this whole function here and to this whole function, you plug in 3 and then you plug in 1 and you subtract them. So I'm going to go, okay, so it's going to be half, if you go to Desmos, half of 0.25, I'll show you it's 0.125. Here, let me just do it real quick. Desmos pops up for me. 0.25 divided by 2. So it's 0.125. So I'm just going to, okay, this is 0.125. And I'm plugging in the 3 there and there. 3 squared plus 4 times 3. And then minus, and then I do the whole function again. Oh, that's what should have been negative 1.25, huh? Negative 0.125. This time plug in the 1 there and there. 1 squared plus 4 times the 1. Like that. Okay, and there's a minus in between. In fact, let me just make that a different color for extra clarity. There's a subtraction between them. So I plugged in 3, plugged in 1, subtract in between. And I would just honestly just go to Desmos at this point and let Desmos handle it. So I got what? Negative 1.25, negative 0.125 times 3 squared. So I go, okay, so um, parentheses, negative 0.125 times, I know 3 squared is 9. Let's do that. Plus 12, 3 times 4 is 12, plus 12, parenthesis, minus parenthesis, and it's going to be negative 0.125 times something, I don't remember, right here, times 1, oh, just times 1 plus 4. So it's just plus 4, really. You don't really need that. I'm just going to go plus 4. Was it 4? Oh, I forgot. Yeah, plus 4. There we go. What's it come out to be? 7. There it is. It is 7. And that indeed is the answer. That's the area. That's this blue area, which I now just made green. That's the area. Whenever you do an integral, you're doing the area between the graph. Any graph could be a straight line, a curve, whatever. Any graph and the x-axis in that from 1 to 3, from 1 to 3. So I found that area right there by doing that. There's 7. Remember, we did it earlier by saying, okay, let's count all the boxes, remember, and it would be 1, 2, 3, 4, 5, 6. And then we had to do a little rectangle here, and then we had to do a little triangle. We add it all up. This is much easier. I mean, fairly easy. This is a little Desmos intensive, but basically you just do the integral, and we learned the big discovery calculus, the integral is the antiderivative. And so there we go.